All right, hello students. Hello. Welcome back. And welcome to Wednesday's video lesson of a review of igneous rocks. So you'll remember yesterday at the end of the Google Slides presentation, you should have been creating this 3-column chart in your science notebook on page 93. And you should stay on top of these assignments, that way you don't have a ton of work to do at the very end. But we wanted to just start today by reviewing that igneous rocks are formed from magma cooling. And there's extrusive, which means they cooled outside, or intrusive, which means they cooled inside the earth. And at the end of the Google form yesterday, there was a challenging, thoughtful question that we wanted you to answer. And we thought we would explain the answer in a bit more detail. And so the Sierra Nevadas are made of mostly exposed granite, but if the granite cooled inside the crust, because granite is an intrusive igneous rock, how come it's so exposed now? And that's because the Sierra Nevadas are right on a fault line, and the western side of them is very gradual and slopes downhill very gradually, and the east side out here by the Mono Basin is very steep. You can see there's a fault line right there, and so millions of years ago the granite formed underground, but as the two continental plates are colliding, they have been pushed up, and they're continuing to be pushed up in elevation, and that granite has become exposed. And so when you go out there, and I'm hoping all of you get to go out there often, as Mr. Nett and I love going out to the Sierra Nevadas, you will see all of these exposed domes and summits, and it's a long chain of basically a big piece of granite that was carved out by glaciers. And here's a more common photo taken from Inspiration Point. And so we have some granite in the classroom that we're going to show you. And we're going to take a look at some of the other types of igneous rock.
Hello. Granite. Hopefully you've held a piece of granite, and if you haven't, as you go across our state to the Sierra Nevada, make sure you pick up a piece. You'll notice it shows those signs of an intrusive rock that cooled inside the Earth's crust because it had time for the minerals to come together and start to form what look like little crystals. You can see the black pieces, the white pieces, the gray pieces. Those are the minerals that make up typically what we call granite. This is what Half Dome, El Capitan, some of those famous points in Yosemite Valley are made out of. And granite, if you've ever picked up a piece, is a very dense, hard rock material. So we make a lot of things out of it as humans. When we talk about the extrusive rocks, the ones that we were having you learn come out to the surface, we have to talk a little more about volcanoes. Hopefully you're familiar with what volcanoes are. So on the whiteboard, drew a little volcano. And as you'll know, magma, which is going to be coming up from the mantle, is going to pool and form what they call a magma chamber. And since this might have been going on in the same locations for millions of years, it has been piling up what has become a volcano. And with extrusive rocks, what comes out of a volcano isn't always the same. Granite is pretty much granite. You can get in different colors and things, but it has those similar characteristics of granite. Volcanic or extrusive rocks come in a variety, depending upon where they came out of the volcano, how fast they cooled, and the minerals that make them up. So now we talk a little bit about some of the magma that rises up here to the top of the volcano. It's probably going to form a pool, and it's going to be bubbling and boiling. If you've ever boiled oatmeal or soup, you'll notice it gets frothy on the top. The lighter elements come to the top. And same thing in liquid rock, the lighter elements, in this case silica, which is in pumice, rises to the top. If the volcano belches out a big explosive blast of rock, the frothy, lighter silica minerals fly into the air. They harden and cool within minutes, and by the time it hits the ground, you have a piece, I'll bring it over, a piece of pumice. So I have a few pieces I can show you. You'll notice it's rounded because it flew through the air, and this actually hardened into solid rock from those silica minerals that had been molten and got aerodynamically shaped, so when it hit the ground it was already hard. You'll also notice, since it was the frothy part of the magma, pumice often has holes in it. Here's another piece. Air pockets, where air got trapped. If you imagine bubbling, even soap in the bathtub with all the bubbles, that would be frothiness in magma. So pumice is found laying usually a little distance from a volcano because it was ejected into the air like little bombs. They rain down all over surrounding the volcano. The magma that's a little more dense and thicker is going to come up to the top also. That's typically what's going to overflow the side of the volcano and form what we call lava. We've seen in videos streaming down. It's made of mostly the mineral type we call basalt. I'll hold up a piece. It's going to be typically what you see if you've ever been near a volcano, this black material, which is basalt. It's much heavier than pumice. It might have air pockets because it's kind of bubbling when it comes out of the volcano and might harden. But you'll notice even the color shows you it's different minerals than the pumice, which is usually very light from the silica, very black, very dark stuff. Depending upon the mineral content, you might get some other colors in there. If our video quality is good, you might see some red in this piece. It's just a different mineral. I'm not bleeding. And even a type they call scoria, which is what we see sometimes on the side of our highways. They use this actually in the mountains for traction on roads. It's reddish kind of material, but it's all in that basalt category of things that overflowed the side and hardened somewhere on the volcano, which also makes the volcano a little bit bigger. The other typical rock people love to talk about with volcanoes is the black, shiny, glass-like rock we call obsidian. And obsidian was magma also, and it's going to harden as it's coming to the surface through the volcano. And you're going to find typically it never makes it out. It usually is one of these branches where magma isn't just coming up in one place, but as it branches out into different veins, you'll find that. And while the volcano is erupting, you won't even know the obsidian's there. Years later, as this erodes away, typically, it'll expose pieces where then we pick up our obsidian. Obsidian they call volcanic glass. It's so sharp you could cut yourself on the edges. It literally breaks like pieces of glass. Little trivia, this is what they use on the finest scalpels to do heart surgery in medical conditions, is obsidian blades. We can actually sharpen it finer than steel. Little tip. Now, we thought since these different rocks have their different characteristics, we do a little lab activity since we can't hand you the rocks through the camera and you're not in school today. We filled up our basin of water, and we're not really talking about sedimentary rocks anymore, but luckily we have this tank, and thought we'd look at the density and test these rocks. Some of you may know where I'm going with this, but here's a piece of granite, pretty heavy, dense stuff. You could hear it hit the counter, goes to the bottom. What do you think's gonna happen with my piece of what we call lava or basalt? 3, 2, 1. Yes, you probably guessed correctly. Goes to the bottom. Even though there's a few air pockets, this is very dense material. Obsidian, it's a nice piece of that shiny rock. Oh yeah, goes to the bottom. And the one I talked about first, pumice, put it in the water. It's rock that floats. There's so much air trapped in what had been that frothy part of the magma that it's probably got more air than it has actually minerals that hardened around the air pockets. So one unique characteristic of pumice is it's a rock, because it's hardened magma, but it floats. Pretty cool. So I wanted to share a little bit of what we'd normally be doing in class, where we'd probably pass these around, and if we ever get back to class, we'll have them here. And we thought we'd go over a little bit more of what's going on because this is Wednesday. So I'm going to pass it back to Mr. English.
Okay, hey guys. So tomorrow we will be introducing metamorphic rock, and we will continue that on Friday as we begin to introduce the rock cycle. And I want to let you know there are going to be some Google form questions for you to respond to today, but I'm also posting the link to the Quizlet for all of the academic vocabulary since we began plate tectonics, and so that includes information about Alfred Wegener and continental drift and plate boundaries. And after plate boundaries, let's see,
We get into the three types of rock.
we're starting to talk about the 3 types of rock, and we'll go into the rock cycle, and then that's what the assessment will be on. So you need to click on the Quizlet link and begin practicing with those flashcards, because in about a week, we're thinking either Wednesday or Thursday before spring break, we're going to send you a digital assessment.
I just had to do that to make sure you're listening. I'm going to ask Mr. English to repeat what he just said is coming up next week.
So we're looking at sending you a digital assessment the Wednesday or Thursday before you go on your official spring break. I realize we haven't been coming to class, but we're hoping that you're staying on top of your work in all of your classes, not just ours. And if you have any questions, to email us. Otherwise, we will see you at the next video, okay? Take care.